Let's transition right into that, because that's probably going to be the main discussion of the night. So this article apparently came out today that you shared with me, and this is awesome. So this is from Palantir. The senior director of enterprise technology, Marcus Loeffler, I might be saying that wrong, discusses the principles underlying his belief that Palantir's Foundry Ontology can transform any enterprise. And they go deep here explaining what the ontology is. Quick little summary of it, and then we'll get into it. He says, I believe there are three principles underlying the transformative power of the ontology. Number one, data analytics and models created by technology are meaningless without connectivity to real-world action, data-driven decision-making. Two, organizations must embrace complexity to survive. This is basically what CARP has been spewing for the past couple months. And three, technology should empower businesses to understand, achieve, and sustain optimum complexity as simple as possible. That right there seems like a very strong core investment thesis, at least for the technology of the ontology. So if we could start from the beginning, we keep hearing this word. What, in layman's terms, is the ontology that Palantir keeps talking about? And then we'll get into sort of why it can change an enterprise.
Didn't you define ontology a few podcasts ago?
I did, but I defined it philosophically, because I did debate in high school, and the first thing we learn is like Kantianism, right? And so the ontology is like the state of being. So, that's, in November 2021, when I was hearing Palantir talk about ontology, I was like, wait a second, this, like Immanuel Kant talks about ontology. Why are you guys like that's what the fuck are these guys? And then I was like, oh, they're talking about like the state of being of the enterprise, and what does it mean for there to be like an understanding of an organization? So it's an interesting philosophical term, but also a technical term as well.
So maybe the question here I would be, we know that the ontology is related to the digital twin. My question, I think many people have, is the ontology a digital twin, or is the argumentation of a digital twin?
So it's definitely a digital twin in the sense that I want to be able to first just think about what the digital twin is useful for, and it's really simulations, right? So like you want to know what will happen, you want to be predictive, not reactive, right? So like that's why the digital twins are super useful, and why people are trying to do digital transformation is it puts you in a position where you're not constantly reacting to things, and as you're reacting, the state of the world is like completely drifted from where you were yesterday looking at your dashboard. The goal with the ontology is to sort of simulate what's going to happen in the real world when an event occurs, or when data, like the things that are going to stimulate the system actually happen, right?
And Coach Chubb, when you mean simulate, you mean literally predict if X happens, Y and Z will happen before that happens.
Before it happens. A good example of that are the simulations that the Ferrari runs, right? Like they're gonna run simulations on different builds of their vehicles to figure out which one's gonna work better, with some degree of accuracy. Because you don't want to go build the fucking thing and then have it like not work. You're not gonna go build 4 versions of it. You want to be able to build the version that's gonna perform the best ahead of time. But there are other things like anomaly detection where you want to make sure you're doing preventative maintenance, on things. And then what's the cost if I do the preventative maintenance? What happens downstream, right? So if you can predict all those things ahead of time, you're in a really, really good position. You can be ultra cost effective. So like what the ontology allows you to do is to model the things that let you do that, which include the linkages between things. So like what type of links are there between these objects? What are the behaviors of the objects? What do they do, right? What can they do? What can they interoperate with? What kind of state can they affect? Can they affect the state of the real world? All of that can be like packaged into ontology actions. So they have this behavioral aspect to them. The other thing that's really cool about ontologies is now they have rules. And so like there's this engine called rules that lets you essentially alert and take actions based on the state of the ontology. So it's constantly evaluating the state of the ontology, or it's not constantly evaluating, but during as part of a batch process evaluating the state of the ontology, and it can take some action based on something. And that's also like a really cool feature of if you think about it, that's a lot of how a business behaves, right? Like when an event occurs, something else happens, right? Mm-hmm. Some person takes an action. And you can do that. You can simulate, you can define those things in these rules engines. And that's that part where they're talking about like process flow later in that article. So they're talking about how do you define like a process flow and how do you make these things connect? And so you can use the rules engine to do that. And then the other thing is the write back capabilities, because what if I want to affect the real world, right? Like what if I want to affect things outside of Foundry? The write back capabilities allow you to essentially embed those behaviors so that it can affect, whether it's a wind farm or whether it's your rig. It can actually make changes in the real world by affecting through write back all of those external systems, right? So then your system actually kind of behaves like the things in the real world, right?
Right.
And that's why it's super. But you need all of those capabilities. Like you can't have just one of those capabilities. And this is kind of an old concept. Like if people have been around a while, we're familiar with domain-driven design, which is a similar kind of thing where you create domain objects around different parts of the real world business you're in, right? And those things have people in the Java world have been kind of building applications in a somewhat kind of similar way, but they were missing a lot of these other components that were in there, like graph relationships, for example. You would have to build a separate graph database to be able to model those things, and that wasn't very popular. So you could never really see the relationships between things. And you can never be predictive about like what paths things tend to take in an organization. And that's where like graph databases are really useful in recommendation engines. But there's a lot of things that you can learn through graph theory about your business, about the way things interoperate. And so like that would be something that was missing from traditional domain-driven design. Workflows, there was a lot of investment in building business process automation back in the day, but it was never part of the core domains, really. This was like a layer on top. Whereas the ontology makes it so a lot of that stuff that might have been business process automation is part of the connective tissue of the ontology. So it's really kind of what I would call a novel way to look at domain-driven design and build these domains that represent the real world in such a way that it actually emulates what's going to happen. So there's a lot of pieces in there. And the other thing about the ontology too is it's not just data, right? It's also models. So like ontologies also contain these machine learning models. You can actually treat those as first-class citizens, and they can participate in a lot of the response to information, right? So like there's an event, but the models can be used to like surface signals, and they can also be used to sort of process the signals, which is really cool. So if you think about how anomaly detection works and how you would build machine learning models for preventative maintenance, you can see how that would be really valuable to have a system that can make models a first-class citizen in all of that, right? So now your system's intelligent. So it's all of those things together. No one has really figured that out, to my knowledge, except for Palantir. And they keep innovating. Like rules is pretty new to my understanding. That came out of this project called Taurus, and that was part of this collaboration they did with BP. And BP used Taurus to make citizen sort of anomaly detection modeling capable, like be able to happen. So like you're an average person at BP, you can now build an anomaly detection system on top of the ontology with Taurus, or it's called rules now, that lets you do things like predict when maintenance needs to happen, right? So it's like that kind of stuff is pretty incredible. Before it needs to happen. But like the fact that they were able, like that's really new. I think the final version of it came out in July of 2022. I don't have an exact date. I'm trying to get that from the team. But so they're continually adding to the ontology. So it's not just a static thing. They're continually kind of working with customers to figure out like these features, these new products that people have discovered in ways to make these things work that can be boxed and offered to other people. So it is continuing to evolve as well. So even if people tried to catch them today on like, oh, maybe I could build an ontology system which emulate every feature, well, they might be like 10 more steps ahead by the time you get that out the door. So good luck.
But, sorry to jump in, Kostrop. I heard many other companies, like also AWS, talking about the digital twin. So what's the difference? Because from my understanding, and here correct me if I'm wrong, it's like the digital twin is like a simulation engine, while the ontology seems like that uses the digital twin, but is something more that is strictly connected to the operations, while the digital twin seems more like I just test scenarios. I'm right?
Well, a lot of companies, when they talk about a digital twin of their organization, unfortunately, it winds up being some kind of like a data representation of the business. So they'll basically say, "Oh, I'm going to make this digital twin, and it's going to wind up being a dashboard of all these things, and that's my digital twin." It's like there's this data representation of what is happening in quote real time, right? Like that's not a digital twin. Like what happens if the operator over here sneezes on this equipment and it goes down? Can you answer that question? Do you know or no? Usually that's a question they have to ask the humans on the other end. Like, hey, Bob, what happens if you spill your freaking coffee all over this thing and this machine goes down? Bob can tell you, because he's probably done it 10 times before, that it is going to screw up the assembly line for however long. It'll take like 20 minutes to repair or whatever. But what's unique with Palantir is you can actually encode that as in these through the actions and through the models to show you what will happen downstream, right? Through and because it can take advantage of links to understand what the downstream effects are, do that. So imagine it's almost like think of the ontology as like a bunch of dominoes, right? You got all these dominoes. You want to know what happened if you push this domino, right? But the ontology provides all of the behavioral modeling along with all of the data information and all of the predictive like AI and ML required to simulate that, so you don't have to do it. So you can see what dominoes are going to fall depending on which ones you push down. And for most people, digital twin, they don't think of that. They don't think that they have to actually create representations that include behavior, not just state, but also incorporate ML, so that you can model complex and sophisticated things, not just heuristics, right? So like in programming, most of what we write are heuristics. They're not perfect representations. They're sort of good enough. And a lot of the ones we use that you typically are going to codify in like a business process are really bad. And being able to bring artificial intelligence in there makes the system like 10 times better. So like if you think of the ontology, think of it as like it's a bunch of features that let you do that domino simulation. And they've combined them in a really novel way under an orchestration engine that makes that possible and not overly complicated. So that whole quote about like embrace complexity, right? Like a lot of people would run away from something that complex. There's that famous quote by Rich Hickey, which basically, says if you're building complex systems, you're going to fail. Like the person that builds the least complex thing is going to win, right? And it's a principle of software engineering. Like we're constantly trying to drive complexity down. And Palantir on some level saying, no, what you're trying to do with digital transformation is complicated by nature, right? You're trying to emulate the real world. And it requires you be able to do things like encode the behaviors of a system and to use artificial intelligence to do it and to provide the links between all those things, so when this thing behaves this way, this thing over here behaves this way, right? That's a really complicated thing, but it's the minimum complexity required to get a good answer, which is also the really novel and unique thing they're saying in there, which is that they feel they found a way to do it right and to basically make that system like a series of Lego bricks that you can put together rather than building this giant monolithic thing that like is really hard to maintain and brittle. And that's generally what they mean when they say like, oh, let's get the simplest version of this, which is like make the most modular, flexible version of that thing that you can. So it's not rigid and will bend and not break, right? So that's in terms of like software engineering, that's how we think about those things.
I have a question on the AI portion of that. So you say when you put AI on top of the ontology, that like hypercharges its effective and efficiency because it's based on these models. So is this where we get into the network effect of Palantir, where it's like, let's say they're working with T-Mobile and they're hypothetically stimulating 10,000 different events from supply chains to logistics to accounting to sales to marketing to come up with a real ontological explanation of T-Mobile's business, hypercharged by these models that are now learning based off all T-Mobile's data. When they go to work with Pepsi next, is that ontology that was or those models that were trained on T-Mobile's ontology, do those get applied to make Pepsi's simulations 10 times better now because they're trained on these models?
Could like a better, like give a better example, like let's just say I'm BP and I'm making an anomaly detection model and I want to run it against this I don't know, this machine over here that runs at a certain rate. And I want to know when the bearings inside it are going to break, and you can build a model in Foundry, deploy it as part of your ontology, and then feed into it the data that's coming into the ontology system and let it trigger some kind of an event or some kind of an action. So the data will come in, the model will give it a score, and based on that, you can take an action downstream against another object, right? Or write back to some other system in addition to that.
Right.
Now, that anomaly detection model might be really useful outside of BP, right? That anomaly detection model for knowing when bearings will break might be useful to Toyota,
Yeah.
There's huge applications for that. Yeah, and like if it's built on the Foundry ontology, even better, if it's built as an archetype, you can just ship that in as an archetype and hit the install button in Foundry and it'll install that model for you.